So we've learned a way to convert degree measure to radian measure to degree measure. That's an important skill for you to have. And what I want to talk a little bit more about what radians are and what's going on with radians. Just to compare, if I asked you how large a 1 degree angle was, I think you all have a sense of 1 degree angle as a very, very narrow angle, right? Incredibly narrow. Um, how wide is a 1 radian angle, though? If you had to draw an angle of 1 radian, what would you do? So let's do this problem. Let's actually figure out how many degrees equal 1 radian. I guess the point is sometimes the way we get a feel for what radian measure is we convert to degrees where we're a little bit more comfortable, right? So let's go ahead and figure out how many degrees equal 1 radian. I'm not going to go through two methods here. I'm just going to choose one. I'm going to use the proportion method. So we want to know how many degrees equal 1 radian. We're trying to solve for x here. And underneath, I'm going to write a relationship I know. I know 180 degrees is equal to pi radians. And I get a very simple equation here. X over 180 equals 1 over pi. And now I can multiply both sides by 180 to solve for x. And x is, now be careful with this one because I end up with 1 times 180 is 180 over pi times 1 is pi. I end up with 180 over pi. The pi doesn't go away. And yet the units here are degrees. I have to write the degree symbol or the word degrees. Kind of funny looking. 180 over pi degrees. Now I'm going to pull out my calculator and actually divide 180 divided by pi. And I see this long decimal. X is about 57.29577953131 degrees. Well, let's just round that off. X is about 57.3 degrees. We're very close to 57 degrees. That's 1 radian. Just observe that 3 radians is going to be approximately 3 times 57.3, which is 171.9 degrees. And the only reason I say that is it's close to 180. That's close to a straight angle. So if you're trying to visualize what an angle of 1 radian is, you can kind of approximate by starting out with 180, straight angle, dividing it by 3. And that's kind of like approximately 60, right? And that's one way. It's not exactly a third, right? Because it's not 60 degrees, it's 57.3 degrees. But I'm actually going to try to write a 1 rad in there. Just to have some idea of what 1 radian is. 1 radian is a significant chunk of a circle. In fact, it looks so close to 60 degrees. Let's maybe call this exercise 6. How many radians equal 60 degrees? What is 60 degrees in radians? And I can set up a proportion. X radians equals 60 degrees. And underneath, I need radians, degrees. So it's 180 degrees, pi radians. x over pi equals 60 over 180. Here I can multiply both sides by pi. I'm going to get x equals 60 pi over 180 when I solve. And I can reduce that fraction because 60 goes into 180 3 times. That's just going to reduce to pi over 3 radians. I just like to look at this one here because pi over 3 radians is 60 degrees. Remember how pi is very close to 3, right? So pi over 3, it's not a third, right? That's a fraction very, very close to 1. It's very close to 1 radian. It's actually a little bit bigger than 1 radian because pi is a little bit bigger than 3. Pi is 3.14. So 60 degrees is a little bigger than 1 radian. Well, that makes sense because 1 radian is 57.3 degrees. And let's see, there's just a couple more things I want to add here. I think I'm going to write this on a separate sheet before we finish this segment. So just here's a fact. A central angle of 1 radian subtends an arc that is equal in length to the radius of the circle. So you got to have a circle if you have a central angle. So what are we saying here? Take a circle of radius r. Okay, a little lopsided, sorry. And suppose this angle is 1 radian. I'm trying to write 1 radian. Try again. RAD. And what we're saying is this arc length for an angle of 1 radian has to equal the radius. So why is this true? Well, remember how theta in radians is S over R. That's on one of our cards. Here it is. My yellow card. So theta in radians is S over R. If we know that's a 1 is S over R, this equation takes this special form. Multiply both sides by R, cancels, and you get R equals S. So we can actually verify that. So that's just an interesting fact. A central angle of 1 radian subtends an arc that is equal in length to the radius of the circle. Just one last comment. Suppose that R is equal to 1 unit, or 1 inch, 1 foot, whatever, just one, let's say inch. Let's give it a life. What's this picture going to look like? So if that's 1 inch, and that's 1 inch, and if that's 1 radian, then this arc length is also 1 inch. And this is a picture on something called the unit circle. We'll talk more about the unit circle later in the course. On the unit circle, an angle of 1 radian subtends an arc of length 1. But maybe let's go back and leave you with the, I'm going to leave you with the fact at the top of the sheet because that's the more general situation.